Hello there, welcome to this lecture. In this lecture, we are going to discuss about an overview of healthcare facility. After the end of this lecture, you would be able to understand about healthcare facility. Then we have to discuss about the infection control in healthcare facility. Then what are the main routes for inspection in healthcare facility? We have to discuss that. After that, we have to discuss about the isolation rooms and the types of isolation room in healthcare facility. So let's start. So now we are going to start first topic, introduction to a healthcare facility. So before starting, the question is that why we are providing HVAC services in healthcare facility? What is our main purpose? So remember, HVAC design for healthcare facilities is all about providing a safer environment for patient and staffs. Okay. So as you know that people in urban settings spends between 80 to 90% of their time in indoor spaces, both during work and during leisure time. So it is therefore important that the architecture and the mechanical engineer work in unison to ensure the quality environment. So a good design can result in healthy and comfortable living, better environmental control, operational efficiency, then lower greenhouse gas emission, increased productivity. So these are the advantages. Okay. That is why we are providing HVAC services for healthcare facility. Now, see, the main purpose of HVAC system is what? Here they have written. So the primary purpose of HVAC is to provide comfortable and safe environment for the patient, staff and visitor. Okay, so this is our main target. Now the question is that how we can maintain the comfortable environment inside the hospital or inside any room, because in hospital we have a different types of room like operation room, operation theater, isolation room and many other rooms. Okay, so here the main, we have to maintain the temperature as per human comfort, as per ASHRAE, American Society of Heating Refrigeration Institute. So as per ASHRAE, for human comfort we have to maintain around 22 to 24 degrees Celsius inside the room. If you maintain that much of temperature inside the room, so it will comfort for environment, for human. Okay, same way relative humidity also in summer season we have to maintain around 50 to 55 percentage for human comfort as per ASHRAE only. Okay, so here the main target of HVAC services is to provide comfortable and safe environment. Next thing, it also has a pivotal role in determining infection rate. Okay, so we have to see that also. So this is all about HVAC for healthcare facility. So now the next topic is how we can control the infection in healthcare facility. So see, for that, in a hospital environment, there tends to be high concentration of harmful microorganism. Okay, so I think all of you know about microorganism. Microorganism are small living things that are found all around us and are too small to be seen by the naked eyes. Okay, so they live in water, soil and in the air. Some microorganisms make us sick, other are important for health also. So now the, what are the advantages, what is the benefit of this organism? I have told you here that some microorganism make us sick but some important for our health. Why it is important? Remember, this microorganism help in processing food digestion, they help in cleansing of environment. Okay, so these are the advantage, but the disadvantage of microorganism is what? They causes disease in humans, animals and plants. They also spoil the food items also. And what are the sources of this microorganism? So remember, improper treated sewage or runoff from animal waste, industrial sources such as slaughterhouses, food and paper processing plants. So these are the sources, okay, of microorganism. Now, from an infection control perspective, you can see here the primary objective of hospital design is to place the patient at no risk for infection while hospitalized. Okay, so this is next. The special technical demand include hygiene, reliability, safety, and energy related issue. So infection which may result from activities and procedure taking place within the facility are a cause of for great concern. Okay. Now see here, there are three main routes responsible for infections. What are that three main routes we have to see? In that, first is contact transmission. Getting? Second one is what? Droplet transmission. And third, airborne transmission. So as I told you, there are three main routes responsible for infection. What are that? Contact transmission, by droplet transmission, or by airborne transmission. Now here I will explain you each and every point, okay, the routes of responsible for infection in detail. Now first one is what? Contact transmission. You can see the contact transmission is the most important and frequent mode of transmission of infection. So this contact transmission may be classified into two types. First is direct contact transmission and second indirect contact transmission. So see, the direct contact transmission is what? So this direct contact transmission involves direct body to body contact. Getting? Direct. For the transfer of microorganism from an infected person to a susceptible host. So it involves direct body to body contact, okay, for the transfer of microorganism from a infected person to a susceptible host. Okay, so this is all about direct contact transmission. Now the second they are showing indirect contact transmission. So this indirect contact transmission involves the contamination of an inanimate object. Inanimate object means what here? Uh, Instruments or dressing by an infected person. Okay, so we know that some instruments are there or dressing of an by an infected person. So through that also the contact transmission will transfer. Okay, getting? So this is all about contact transmission. Now we have to discuss the second, droplet transmission. What is, how this droplet transmission are responsible for infection? So see here, this droplet transmission, you can see droplet transmission occurs when an infected person generate droplets containing microorganism. You can see in this image, okay, how the one person can generate droplets containing microorganisms. So simple in language, you can say droplet transmission occurs when an infected person generate droplets containing microorganisms which are propelled at a short distance through the air and deposited on the conjunctiva, nasal mucosa or mouth of a host. Okay, so droplet do not remain suspended in the air, so special air handling and ventilation are not required to prevent droplet transmission here. Okay, second point, it is written here, a person coughing, sneezing and talking generate droplet. Okay, other procedures such as suctioning and bronchoscopy are also a source of droplet. Okay, so this is all about droplet transmission. Now the third one and last is airborne transmission. So what is airborne transmission? See how this airborne transmission is responsible for infection. Airborne transmission occurs when either airborne droplet nuclei or dust particle disseminate infectious agents. What is actually this droplet nuclei? Say, remember, the high velocity with which coughing and sneezing expel droplet from the respiratory tract result in large numbers of bacteria or viruses entering the air in a smaller droplet. So these droplets rapidly evaporate in the air, leaving a residue of typical 5 micrometer or smaller in size. So these droplet nuclei settle so slowly that they remain airborne in occupied spaces and circulate on air current until mechanically removed by the ventilation system. Okay, so this is all about droplet nuclei. Now the next one, it is written that airborne transmission occur when either airborne droplet nuclei or dust particle disseminate infectious agent. So this dust contaminated by viable infectious agent may build up as a reservoir capable of causing an outbreak of infection. Even after the departure of the infectious patient from whom the pathogens originated, dust may become contaminated when dried sputum and other infectious secretions suspended in the air as dust particle mix with environmental dust. Okay, so this is all about airborne transmission. Okay, so these are the main routes which is responsible for infection. Getting? I hope all of you understood this. Now come to next topic, isolation room. Okay, so now we have to discuss about isolation room. What is actually isolation room? What is the main purpose of this room? So see, the purpose of an isolation room is to act as a barrier. Getting? Its purpose is to prevent the transmission of microorganism from infected patient to other patient. Okay, our main target is what? Why we this isolation room is there in hospital? Because we have to prevent the transmission of microorganism. I have told you what is actually microorganism, and some microorganism make us sick, but some are important for us also. Okay, so by using isolation room you can prevent the transmission of microorganism from infected patient to other patient. Okay, so the infected patient can as we know that the infected patient can contaminate the environment. Okay, so a single room with appropriate air handling and ventilation is particularly important to prevent direct or indirect contact transmission, and also for reducing the risk of airborne transmission of microorganism from a source patient to susceptible patient and other person in hospitals. Okay, now see, this isolation room may be classified into two types. We have a two types of isolation room. In that, first is what? Airborne infection isolation. In short, you can say AII. Airborne infection isolation room. Second, we have a protective environment isolation room. Getting? So AII or PE. So there, this isolation room, we have a two types of isolation room. I think all of you clear this. Okay. Now see about one by one. Airborne infection isolation room. So remember, this airborne infection isolation, it refers to the isolation of patient infected with organism spread via airborne droplet nuclei less than 5 micrometer in diameter. Getting? These include patients suffering from measles, chickenpox, and tuberculosis. Okay. Other area include the emergency department, intensive care unit, and procedure areas such as bronchoscopy suites or sputum induction rooms, etc. Okay. Now the next is second one is protective environment isolation room. So this protective environment, in short PE, is a specialized area for patients who have undergone allogeneic hematopoietic stem cell transplant. In short, you can say HSCT. Okay. See, the patient whose immune mechanism are deficient because of immunologic disorder. So for that we have a protective environment isolation room. Here see, one point is written, human immunodeficiency virus means HIV inspection are also placed in protective environment only. Okay. So example is written here, some chronic diseases or immunosuppressive therapy, example radiation, organ transplant, are also placed in protective environment only. Okay, so this is all about the types of isolation room. So now here we have to see that how does above classification which I have shown you, okay, affect HVAC designer. So first of all, we are talking about C. The differentiating factor between AII means airborne infection isolation and protective environment room in the pressure relationship. So here first of all we are talking about airborne infection isolation. So in this room generally, first of all, airborne infection isolation room or simple isolation must be maintained at negative pressure. Here as I told you that we have a two types of isolation room. Okay, first airborne infection isolation room, second protective environmental isolation room. So airborne infection isolation room must be maintained at negative pressure here. Okay, remember this point. Second, these are required frequent air changes greater than 12 per hour. Air changes means in 1 hour we have to change the air. How many times? More than 12 times. Okay, to maintain the comfort environment inside this airborne infection isolation room. Getting? Next point is required, this room means AII room required all supply air to be exhausted without recirculation. So remember, while designing airborne infection isolation room, you have to remember whatever condition air you are supplying inside this room, AII room. So 100%, see here it is written, required all, whatever, suppose you are supplying 1000 cf, just I am taking one example, suppose you have done the heat load calculation and you have got 1000 cfm, means we have to supply 1000 cubic feet per minute, that much of conditioned air inside the isolation room. So remember, in case of airborne infection isolation room, you have to exhaust 100% of that supply air to the, okay, atmosphere. Don't need to recirculate that air. Here we have to exhaust 100% of that air, and again fresh air you can supply inside this room. Okay, so remember this point. Now the second one is what? Protective environment isolation room. In that we have to see, first is the protective environment are set at positive air pressure. Getting? Here the pressure we have to maintain positive. Second, these area required frequent air changes greater than 12 per hour. Okay, here also same, in 1 hour we have to supply, we have to change 12 times we have to change the air to maintain the, to improve the indoor air quality, you can say. Second, these room required all supply air passing through high efficiency particulate air, means with HEPA filter. Here before supplying the conditioned air in this protective environment isolation room, we need to install or we need to place the HEPA filter here, because here HEPA filter can filter the air. What is HEPA filter? All of you know, I think. It is a special type of filter which can purify the air up to 99.97%. and where we can use this type of this HEPA filter. So some application is there for clean room application like hospitals, pharmacy or medicals. HEPA filter is used, okay, and it is used for removing particles 0.3 micron in size. See how small particle you can remove from this filter. So it is used on the supply air distribution of the protective rooms, okay. So the HEPA filter remove particulates such as microorganism from the air. Here remember both, either it is a airborne infection isolation room or protective environment isolation room. Both these areas required inline monitoring to ensure that they remain under set pressure. Door to the room should be self-closing and the walls, windows, ceiling, floor and penetration well sealed. Okay, remember this point. So this is all about an overview of healthcare facility. So if you are interested for complete designing of healthcare facility, so our Udemy course is available. In description you will get the link of that course and you can just enroll and enjoy it. So I hope all of you enjoy this session. See you in next one.